So how many extraneous solutions? And let me just write this out. So I have 2m divided by 2m plus 3 minus 2m over 2m minus 3 equals 1. So again, we're solving for our extraneous solutions. So what does it mean when we talk about extraneous solutions? We're talking about kind of holes or discontinuities, specifically a removable discontinuity in our equation here. So take a moment to think about this. Again, this is a rational expression, right? We have a fraction. That has a 2m plus 3 as a denominator, and we have 2m minus 3, right? So we have to use something called lowest common denominator in our rational expression. So again, take a minute to think about this question, and then we will take it up together. Here, I don't like this m here. There you go. So we think about lowest common denominator. How do we combine both of these fractions to make sure that they have the same denominator? So if we're given this problem here, and I want to isolate for this m value here, what I'm going to have to do first is I'm going to have to put all these two terms here in a lowest common denominator. So this is here's 2m plus 3. This is 2m minus 3. I need them to be in the same denominator, which means I need to multiply this term by this term here. So I'm going to get something like this. So 2m plus 3 is going to be at the bottom. I'm going to multiply it by this lowest common denominator, because I need basically a similar term for both of these denominators, so I can combine the numerators, right? So this here would be 2m minus 3, and then at the top of this problem here, I'm going to get 2m multiplied by 2m, right? Because I have 2m here, and I need to multiply by this m here as well, because this m is part of this this fraction here. And similarly, what I'm going to have to do with this one here is I have 2m minus 3. I'm going to have to multiply that by 2m plus 3 to get the same denominator. And then I can do the exact same thing. It's 2m times 2m here. 2m times 2m. And that's going to equal 1, right? Here. And now I can simplify this equation here, right? I can simplify this equation. I can put them all into one kind of fraction. So I have here, this is simply just 2m plus 3, 2m minus 3, and I have 2m times 2m, which is 4m squared, and this here minus is 4m squared as well. So what I can do now is I can, let's see, this here will equal 1. And then what I'm going to have to do is, I'm giving this rational expression here. I kind of have a difference of squares at the bottom, because I have 2m plus 3, 2m minus 3. So I could rewrite this into something like this. So it'd be 2m squared, and then it'd be whatever 3 squared is. So this would be 4m squared minus 9 would be my difference of squares. Kind of a thing over here. 4m minus. Oh, hold up. I think I did the wrong thing. My bad. Sorry. I caught myself as a mistake. So give me a second. Let me rewind. So I am multiplying not by 2m here. This is not by 2m. I'm multiplying this term by 2m minus 3, right? This here is 2m minus 3, and this here is 2m plus 3. And the reason why I'm doing that is I'm basically multiplying by 1 here, right? These two terms divide out to 1, and these two terms are dividing out to 1. I'm not simply throwing 2m randomly over. So that's my fault. I multiplied the numerator instead of the denominator. Sorry about that. So I have this new term here. I'm going to do the distributive property. I have 2m times 2m here, which is 4m squared. 4m squared, and then 2m times minus 3 here is minus 6m here. Similarly, I have this is going to be minus, and then this entire, it's subtracting this entire term, right? So this entire term is going to give me minus. So I'm going to put a little bracket here. This is again 4m squared minus or no, this is positive 6m, positive 6m. So what I can do is I can then simplify this bracket into, this is 4m squared minus 6m minus 6m. Okay, it's simple. So this here is now minus 4m squared minus is minus again, minus 6m here, right? I'm breaking down this bracket. I'm using this negative applies to all of this entire bracket here. So this here equals 1. And then I can see that 4m squared and 4m squared cancel out. Minus 6m is minus 12m, right? So you have minus 12m divided by 4m squared minus 9, right? And that's going to be my kind of equation here. So here equals 1. And then let's see, what else can I do with this variable here? I can simply just multiply the denominator to the other side, right? I'm isolating from my m here, right? So I have my negative 12m equals 1 times 4m squared minus 9. And then what I can do is I can bring this 12m to this side, right? To the right side to rearrange it to become a quadratic function here, right? So I have 4m squared. This will be plus 12m now minus 9 equals, or equals 1. Sorry, this here still equals 1. Equals 1. Let me just erase these guys here. And then I can simply bring 1 to the other side to make it 0, right? So this here would be 4m plus 12m plus 1. I'm going to subtract 1 from both sides. So negative 9 minus 1 here. So I have negative 9 minus 1, which will give me negative 10, right? Equals 0. Now what we can do is you can choose to do two approaches. You can either factor out the 2 because they're both even terms. So we can factor the 2 first and then see if we can do factor by inspection. So let me do that. I can factor the 2 here. I'm left with 2m squared plus 6m minus 5 equals 0. And then I can bring 2 to the other side. So it cancels that out. So I have 2m squared plus 6m minus 5 equals 0. And then what I can do is I can do a factor by decomposition. Right? I have the product of 2 times negative 5 here. I will do this in blue. Is negative 10. Product here is that. Sum of it has to equal to 6. So I'm looking for 2 numbers that equal 6 here. So 10, 2 and 5, or 1 and 10. I don't think this is factorable. Let me just check. Negative 10 and 6. I don't think this is factorable here. So this is 2, 6, and negative 5. Oh no, this is factorable. Well, it's just I have to use quadratic formula in this case. Which means I could use quadratic formula to solve for my m value here. It's because this here is, I can't factor by decomposition, which means I have to factor by quadratic formula. Again, what I'm going to do is, I'm going to, for the sake of time, I'm going to, I will write out the formula here, b squared minus 4ac all over 2a, and I'm going to just use my calculator and cheat a little bit, and for the sake of time, I'll just plug it into a calculator. I'm sure by now, by grade 11, grade 12 math, you should know how to use a quadratic formula. So this here, x here would give me 0.68, and I also get a value of negative 3.67. So these two are my m values. Sorry, this here is the m value of these two functions here. And we were looking at extraneous solutions. So do I get an extraneous solution in this case? Could I actually is there discontinuity in terms of the top and the bottom? In this case, no, right? I couldn't cross anything out between the numerator and the denominator when we're doing the rational expression. So in this case, our answer here would be 0. So let's look at this function here. So they rewrote this in terms of, they moved the 1 actually to the other side first, and then they did denominator, which is fine. And then, let's see. Let's see here. Move on to the other side, and they use lowest common denominator. That's exactly what I did here. They've collected like terms. So you get negative 4m squared plus 9 at the very end here, because these guys cancel out. 4m squared and 4m squared cancel out. You're left with negative 4m squared, and then negative 9 plus 9. Or sorry, negative 6 positive 6 gives you negative 3 here. And then you can just simply just move this to the other side and you rearrange and get a quadratic equation. So in terms of extraneous solutions, this here is not, this here you get you get two solutions in this case. Because you have a 0.868 and negative 3.67. So in this case, we get two solutions. But when we talk about an extraneous solution, what is an extraneous solution? So remember, when we're solving for roots, or in this case, when we're solving for roots, we're looking at types of discontinuity, right, or a missing solution, right? So in this case, we only know if a solution is extraneous if we could kind of cross it out, right, in terms of our if we could cross it out in terms of in a rational expression here. So when we talk about solutions here, negative 0.68 and negative 3.67 is indeed our solution for this problem, but it's not particularly an extraneous solution. I didn't cross anything out in terms of my rational expression. So this question is kind of misleading, and I think this answer here says here, since this is a quadratic equation and a quadratic always has two solutions, that's not always correct actually. A quadratic solution could have 0, 1, or 2 solutions. Hence option C is the correct answer. So they thought option C was the correct answer. In this case, because the question is asking how many extraneous solutions does the equation have below, this here is actually the wrong answer. So when we talk about extraneous solutions, require you to cancel out a term or an expression from the numerator and the denominator in a rational expression. Or let me do terms. Cancel out a term from the numerator and denominator in a rational expression. In this case, we did not have to do that. Indeed. So I'm going to say the solution, the question itself has two solutions, like you said. However, none of them are extraneous. So they did their math right. The math here is right, and I did the math here as well. But our math is right. But in terms of when we classify them as an extraneous solution, this is not an extraneous solution. This is simply just the root or the actual solution if we solved for m value here. So this solution I'm going to say is incorrect here.